Hello, hello, welcome back for Chapter 6, Lesson 2, Properties of Parallelograms. Before we get started, we have some warm-up problems. Number 1, number 2, number 3. For number 1 and 2, you're going to use this figure. For number 3, you're going to use this figure. And here's my friend, the Pause Dragon. Remind you to pause your device, work out those 3 warm-up problems. When you get done, press play and we'll talk about them. All right, see you in a bit. Okay, let's see how you did. So I'm looking at number 1x. And the first thing I notice about this problem are that these lines are parallel. Okay, I got parallel lines and then it looks like I have a transversal here. So they both have x, and remember this is same side interior angle. So if you have 2 parallel lines cut by a transversal, the same side interior angles add up to 180 degrees. So what we know is we know that this angle plus this angle equals 180 degrees. So it's going to be 61x plus 29x equals 180. We simplify, and 61 plus 29, I think that ends up being 90. Yeah, 90x equals 180. Then we do division property of equality, divide by 90 to both sides, and 180 divided by 90 is 2. So if you got 2, awesome job. If not, just fix your problem. Okay, now we're looking at y, and if you see here, we have those same parallel lines. There's a y here and a y here. It's cut by this transversal, and so what we have here are alternate interior angles, and we know that when you have 2 parallel lines, the alternate interior angles are congruent to each other, or they equal each other. So that's our equation. 8y equals 6y plus 8. I'm going to get the y's on the same side, so I'm going to use that subtraction property of equality. 8y minus 6y is 2y. And then we just use that division property of equality to get y by itself, and we get y equals 4. So if you got that right, great. Lastly, we have this problem we're trying to figure out with z. I have a triangle. I have a right triangle. I know that all of the angles in a right triangle add up to 180 degrees. So I'm just going to say, I'll say measure of angle z plus 72 plus, that's a plus 90, right, equals 180. And then we simplify. Measure of angle z, what is that? 162. And then we subtract, use that subtraction property of equality, those cancel. What does that equal? We gotta borrow 18 degrees. That sounds about right. So that means z equals 18. Okay. And that is it for the warm-up. So if you got all 3 of those right, great job. And if not, go ahead and fix them so they are correct. Okay, but let's move on. Okay, so that's our warm-up. So parallelograms, right? This whole section is about the properties of parallelograms. So a parallelogram, what that is that is a quadrilateral. Remember, a quadrilateral, quad means 4, right? So it's just a 4-sided figure. So it's a 4-sided figure, a quadrilateral, with 2 pairs of parallel sides. And you can write that as the parallelogram ABCD. Also, you can use this little symbol right here. That little symbol means it's a parallelogram. So that little symbol, ABCD. And here is a parallelogram. If you see, there's 2 sets of parallel sides. So we see that right here, AB is parallel to CD, and you see that right there. And also, that's one set, and then the other set is BC. You see those 2 parallel lines is parallel to AD there. So they called it DA, but same as AD and BC. Okay, so there's 2 sets of parallel sides. That's what a parallelogram is, and you call it parallelogram ABCD, or this notation here. Okay, so now that we're going to talk about 4 theorems that go along with parallelograms, this whole section is about parallelograms. So the first one right here, what it states, this is theorem 621, properties of parallelograms. It says if a quadrilateral is a parallelogram. So what you have, that's the key. You have a parallelogram. So if a quadrilateral is a parallelogram, then its opposite sides are congruent. Okay. So this is theorem 621, properties of parallelograms. Okay, if a quadrilateral is a parallelogram. So if you have a parallelogram, right? So this only works if you have a parallelogram. Then its opposite sides are congruent. Then its opposite sides are congruent. And this is the quick way to write it. So if you have a parallelogram, that's what that means. Then the opposite sides are the congruent. So we have our parallelogram right here, and that means that AB and CD, these are the opposite sides. They are congruent there, and also BC and AD are congruent there. Okay? So the opposite sides are congruent. Okay, that's the first one. Let's talk about the next one. It says if a quadrilateral is a parallelogram, so we have this parallelogram again, then its opposite angles are congruent. Interesting. So if a quadrilateral is a parallelogram, so you have to have a parallelogram, then its opposite angles are congruent. And the shortcut for this one is just if it's a parallelogram, then the opposite angles are congruent. So if you look, the opposite angles, these are the opposite angles. Congruent means these are the same, and also these are the same here. Okay, so angle B and D are congruent, and angle A and C are congruent. They're the same, but they're not all congruent to each other, okay, because this is one arc mark and those are two arc marks, okay? So that's the second theorem. The third theorem right here states if a quadrilateral is a parallelogram, so we have that again, it has to be a parallelogram, right? Okay, so if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Okay, consecutive. That means the angles that are right next to each other, right? So opposite angles are across. So B and D are opposite right here, and A and C are opposite. Consecutive means they're right next to each other. So like angle A and angle B, they're supplementary. That means they add up to 180 degrees. B and C, they are supplementary. That means they add up to 180 degrees. Measure of angles C and D, they are consecutive angles and they're supplementary. That means they add up to 180 degrees. And finally, angle A and angle D, they are consecutive. They're right next to each other, so that means they're supplementary, which means they add up to 180 degrees. So if you have a parallelogram, then the consecutive angles are supplementary. That's a lot of information. So if we have a parallelogram, we know the opposite sides are congruent. If we have a parallelogram, we have the opposite angles are congruent. And if we have a parallelogram, then we know that the consecutive angles add up to 180 degrees. Very interesting. So here we go. This is the last theorem for this section. It says, if a quadrilateral is a parallelogram, okay, then its diagonals bisect each other. Okay, so if a quadrilateral is a parallelogram, then its diagonals bisect each other, and that's the shortcut, okay? Now, I shouldn't have to say this, but I'm going to. All four of these need to be on a flashcard. You need to memorize these. Flashcard. Okay, all four. Okay, back to this one. It says, if a quadrilateral is a parallelogram, then its diagonals bisect each other. Okay, that means they cut them in half. So this diagonal cuts this one in half, so that means these are congruent. So BZ is congruent to ZD, that's this one right here. And also this diagonal bisects this. Remember, bisects means cut in half, so that means that they are congruent. But that doesn't mean they're all the same. This means that these are congruent and these are congruent. So AZ is congruent to CZ. All right? Perfect. That was a lot. So let's go over them again. If you have a parallelogram, opposite sides are congruent. If you have a parallelogram, opposite angles are congruent. If you have a parallelogram, the consecutive angles are supplementary, which means they add up to 180 degrees. And lastly, if you have a parallelogram, the diagonals bisect each other, which means they cut each other, they're congruent, and they cut each other in half. All right, let's look at some problems. So these problems here, these I want you to kind of appreciate, okay? But we're gonna look at it first, okay? So let's not look at the answer, okay? We're gonna cover up the answer. Don't cheat, no cheating, no cheating. Okay, so we're just gonna look at this. All right, so what do we have? It says okay, this means parallelogram. That means we have a parallelogram, which means boom shakalaka, all of these are up for, like, these all apply. Okay, this opens the treasure box of all of these 4 theorems. Every time you see this, this means that you're dealing with a parallelogram. Whenever you're dealing with a parallelogram, all of these are applicable. So we're just gonna have to figure out, well, which one are we gonna use? So, okay, I'm covering it up. All right, so it says in parallelogram CDEF, DE is equal to 74. So DE is equal to 74. DG is equal to 31. And the measure of FCD, okay, that whole thing is equal to 42 degrees. What we need to find is CF. CF. Okay, so we need to find this right here. So what do you think? What are we going to use to figure this out? Well, first, what's given? What's given is that it's a parallelogram, which means this is all of this. It opens the treasure box to all 4 of these. Now, which one are we going to use? I would say, see, we're talking about a side length here and a side length here. So we're probably going to use this one dealing with the opposite sides, right? This one's dealing with angles, this one's dealing with angles, and then this one's dealing with diagonals, okay? So that has nothing to do with side CF. The only one that has to do with side CF is this one right here. If it's a parallelogram, then the opposite sides are congruent. So basically, what we're probably going to end up saying is that, number one, hey, we have a parallelogram that's given, and because we have a parallelogram, we know that if you have a parallelogram, the opposite sides are congruent. We know the measure of this DE, so by substitution, we know this CE. It's either going to be substitution or transitive property of congruence. One of the two. Okay, so let's look at it. So the first thing is it's given this, right? DE, so we're just appreciating this. DE equals 74 millimeters. I'm also going to say, given that we are given a, we're given a parallelogram. So parallelogram CDEF, okay? So you have to write that given piece of information. It's right there. Then what do we know? We know that CF is congruent to DE because if it's parallelogram, then the opposite sides are congruent. We're going to change that format, right? Definition of congruent segments. And then we're just substituting, right? So we know that DE is equal to 74, so we just substitute that in, and boom shakalaka, we have what CF equals. CF equals 74 centimeters. All right, let's look. Does that make sense? You guys got it? Okay, let's look at the next one. Okay, here, we're gonna kind of cover this up. Don't look at the answers on your, I know they're on your note sheets, but don't look at them yet. Okay, so it says in parallelogram CDEF, right? Oh, that means it opens up the door, the treasure box for all 4 of these. In parallelogram CDEF, DE equals 74, DG equals 31, and the measure of angle FCD, that angle there, is 42 degrees. We need to find the measure of EFC. EFC. Ooh, so we need to find this angle here. Okay, so what do you think we're going to need? Okay, so we know this is a parallelogram, so we're trying to find this angle. We're given this side, we're given this diagonal, and we're given this angle right here. So if we know it's a parallelogram, we're trying to find an angle, right? So we're not going to be using this side information. This is dealing with opposite angles, and we don't have opposite angles. What we have is we have 42. This is 42, and then we're trying to find this angle right here, right? And those look like consecutive angles, right? So we're most likely going to be using this one. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So, come on now. Why can't I get this off? All right. So what do we have? We are given measure of angle FCD, right? And then we need to say, that's given, and then we need to say the parallelogram. We also have a parallelogram, right? You have to state that. CDF, and that's given. We are given a parallelogram. Because of that, we can say that the measure of angle EFC, this angle, plus the measure of angle FCD, which is this one, equals 180 degrees, because if you have a parallelogram, this consecutive angles are supplementary. Boom. Then you substitute, right? Measure, because we have the angle for this, so we just put 42 in there. And then it's just some good old-fashioned subtraction property of equality, and then boom shakalaka, there we have it. The measure of angle EFC equals 180 minus 42, which is 138 degrees. And that is just simplify. Okay? Are you guys seeing this? Is it making sense? Okay, let's look at the next one here. 1C, I'm covering up. It says, what does it say? Okay. In parallelogram CDEF, oh my goodness, it's a parallelogram, so what does that mean? Oh, it means we have all access to all these. It unlocks the treasure box, the parallelogram treasure box, okay? What does it say? It says DE is 74, DG is 31, and measure of angle FCD is 42 degrees. We need to find DF. DF, ooh, we need to find this whole thing. Okay, so what do you think? What do you think? Which of these do you think we're going to be using? Do you think we're going to be using opposite sides are congruent? No. Do you think we're going to be using opposite angles? No. Do you think we're going to be using consecutive angles? No. We're talking about a diagonal. So when you're talking about a diagonal, you're going to use this one. If a quadrilateral is a parallelogram, then its diagonals bisect each other. Okay? So that's going to be the one that we're going to use. So let's go ahead and appreciate. The first thing we have to do is say the given information. So we're using this DG, right? We're saying that DG is 31, okay? So, and then we're also going to say that we have a parallelogram. That's super important. Parallelogram CDEF. That is given information. Then we have DF is equal to 2 DGs. So since we know that this whole thing, right, and this is bisect, which means this and this are, they're both 31, right? So that means that the whole thing are 2 DGs. So DF is equal to 2 DG. And that's basically, if you have a parallelogram, then the diagonals bisect each other, okay? This is kind of like the midpoint. You remember the midpoint where we did back in chapter 1 where there was like 5 different things? Like you could say like this is equal to this one, or you could say like the whole thing is equal to 2 of those, or you could say the whole thing is equal to 2 of those, or you could say like this is equal to half of the whole, and this is equal to half of the whole, so there's 5 of them. So that's the same thing here, okay? So it's just using DF, the whole thing is equal to 2 of these, right? Because this and this are the same, and there's 2 of them, okay? So DF is equal to 2 DG, because if it's a parallelogram, the diagonals bisect each other. DF, and then we just do substitution, right? DG is 31, we substitute it in, and then boom, there you have it. DF is equal to 62, just 62. DF is equal to 62. Okay, you see it? You see it? All right, cool. Let's go ahead and work some of these out now. Let's see. How about you try this one? Let's see how you do. Where's my friend? Here's my friend, the pause dragon. Remind you to pause your device. Go ahead and work out example 1A. When you get done, press play and we'll talk about it together. All right, see you in a bit. Okay, let's see how you did. So what are we dealing with? In parallelogram, KLMN. Okay, so we have a parallelogram. That means we have access to all 4 of these. Beautiful, beautiful. It says LM is equal to 28. LN is equal to, what's LN? LN, oh, the diagonal, 26. And the measure of LKN, so this angle here, is equal to 74. We need to find KN. KN. Ooh, okay, so we're looking for this KN. And what are we given again? We're given LM, which is 28. So to me, we're doing the opposite sides, right? So we're going to be using this one. If it's a parallelogram, then the opposite sides are congruent. So we have to say that given information. So the first thing I'm going to say is that we have a parallelogram, right? Parallelogram KLMN. And then also this given information, LM is equal to 28. And both of those are given pieces of information. Then I'm just going to say these 2 are congruent. So LM is congruent to KN, right? Because if it's a parallelogram, then the opposite sides are congruent. And then we have to change the format, right? Because we're going to substitute that in. So it's just LM is equal to KN. Because of definition of congruent segments. And then lastly, just substitute in, right? 28 equals KN, that's substitution. And then we always want to have this, and you might have done your problem where your KN was on this side, but mine's not. So we have to do that symmetric property of equality and just flip-flop it. So that is, let me give it a 5. Symmetric property of equality. All right, so if you got that one right, awesome, awesome. Okay, let's go to the next page. We have example 1B and example 1C here. I want you to go ahead and try both of those. And here's, my friend, the pause dragon. Where are you at? The pause dragon, remind you to pause your device, work out those 2 problems. When you get done, press play, okay? And we'll see how you did. You can do it. Let's go. Okay, let's see how you did. All right, so what does it say? It says in parallelogram, KLMN, LM is 28, so this is 28. LN, the diagonal is 26, and the measure of LKN, this one is 74. We need to find the measure of NML. NML, ooh, this one right here, this is the one we're trying to find. Oh, that's fun. Can you tell which one it's, so it's a parallelogram. That means we have all of these, right? Which one is it gonna be? We're trying to find this angle. So obviously we're not gonna use opposite sides. Here we have opposite angles are congruent. Do we have opposite angles? Yes, we do. We're trying to figure out this one and we have this one, right? So these are opposite angles. So that's the one we're going to use. If there's a parallelogram, if you have a parallelogram, then opposite angles are congruent. Perfect. Okay, so let's do it. Yeah. Okay, so we have to say the given information first. So we're going to say we have a parallelogram, right? And we're going to use this angle here. So measure of angle LKN is equal to 74 degrees. And that's given. Okay, then we're going to say that angle NML is congruent to angle LKN, because if it's a parallelogram, then the opposite angles are congruent. Okay, we need to substitute this in, so we're just going to have to change the format, right? So that's definition of congruent angles. And then we just substitute, right? So LKN is equal to 74. We substitute that in, and we get the measure of angle NML equals 74 degrees. Substitution. Did you get that right? If you did, good job. Okay, let's go ahead and try 1C. 1C says find LO. Ooh, LO. What do we have here? Okay, so we have the parallelogram, right? So that opens, unlocks the door to the treasure box, all right? We have LM is 28. We have LN is 26. So here we're given the whole thing. We're given the whole thing is 26, and we just need this part right here, LO. Okay. So we can use one of those, like we know that LO is equal to, these are the same, right? But we know that LO is equal to 1/2 of this, right? So that's, we can say that if a parallelogram, if it's a parallelogram, then the diagonals bisect each other, right? They cut them in half, which means that LO equals 1/2 of LN. So that's probably going to be the formula, like 1 out of the 5, right? That's the one we're going to use. So let's get started. Let's go ahead. First, let's state it's a parallelogram, right? Parallelogram KLMN. And then what are we going to say? We're going to say, oh, right. We're going to use the whole diagonal. So LN is equal to 26. That is given. And then we are going to use the bisect one. So we're going to say LO is equal to 1/2 of LN. And that's because if it's parallelogram, then the diagonals bisect each other. Okay? Now we're just going to substitute in. Okay, so 26 in here. 26 in here for LN, so we got LO equals 1/2 26. That's substitution. And then 1/2 of 26 is just 13, and that's simplifying. And that's our answer right there. Yeah. If you might have done it this way with the, and that's okay if you would have done it this way too. So can you see this right here? So you would need to say that this is a parallelogram, right? And then if you use this formula, LN equals 2LO, the whole diagonal here equals 2 LOs. You could have done that. I don't know, you might have done that. And then if you substitute 26 in for LN, and then you just would have had to solve and use division property of equality, and then 13 equals LO, right? 26 divided by 2. So that would have been like another way to do it, which is fine. Either way on this one is fine. Okay, so that's it for example 1. If you got that right, you did a wonderful job, and I'll see you in a little bit for example 2.